Hi guys, good morning. Welcome back to the new video. And oh god, if you have to solve this question in a contest, it's easy. It's very easy. If you have to solve it in an interview, and then the interview is gonna ask you, okay, what's the intuition behind why you thought of this as an optimal approach? I've not seen any. I was thinking like it's an easy question, like not to make a video on that because it's very easy and like many resources are available. But no one told the intuition behind how you actually will think in an interview, because giving an answer, okay, it's gonna happen, it's not gonna work in an interview. You have to go through a path how you reach to a solution, and not you have to give the answer. Cool. Let's quickly jump to the problem statement. We'll see four methods. The last one will be the most optimal one. And for sure, if you have to solve it in a contest, then I will recommend method 3 as the contest approach. But for the actual interview, method 4 will be the one which you're going to be applying in the interview as the most optimal solution. Let's quickly jump on the problem statement. It's very easy. Single and number 2, we have an integer array called as nums, where every element appears 3 times except for the one element. So basically, if we have numbers, so every element is occurring 3 times except the one element which is occurring only exactly once. Cool. We have to find that single number which is occurring only once and have to return that number. Cool. Now it is saying that you have to do it in a runtime of O of n nearly, and also constant space is O of 1. So as we look at the example, first very normal, very standard thing that comes in our mind is, okay, we have to find the element whose frequency is 1, right? So it's just simply what we can do is, as a brute force, a very simple solution is, as the question itself was saying, have to find the element with a frequency as 1. So quickly go and find, okay, what every element has a frequency of, and then if we know, okay, if these are all the elements, every element has a frequency, we'll just go and count the frequency of every element, update in our map. We can take any hash map, an ordered map, anything, then update in our map, and then by this I know, okay, my map looks something like this, element and its frequency, and I will just go and iterate on this entire map, see, okay, what element was there whose frequency was 1, and then simply return that as my answer. It is simple, which is a standard thing. Okay, we have to monitor the frequency, which means kind of using a hash map or an unordered map, and then by this you can simply go. But you can see time is O of n because simply we're iterating on the list, but space is O of n because we are using a map. So for sure, we need to optimize that. Let's quickly see that how we can optimize the space, which means not use map at all. Now, as I'm saying not to use a map at all, which means I have to find some pattern in this problem that maybe out. If I see that pattern, maybe I will be able to figure out how I cannot use the map or space at all. So now my thing was, okay, figure out a pattern that I can use to solve this problem. I saw every number is occurring thrice except one number. If I leave that except one number part, so one thing is for sure that every number will occur thrice. Every number is occurring thrice, and if I club every number together, which means I brought out every number together, then I will for sure see that the mid number, if I just point to the mid number, then the left and the right will for sure be same. If I point to a mid number, see, which means if I club the same number together, same number as in simply sort it down. Now, I am considering I don't have the extra one element right now. If I have only these 3 elements, these three, then for sure, if I had not been with that 3, which I had earlier, I have only these 3. So if I had clubbed all these same number together, if I point to the middle number, then left and right should have been same. If I go and again point to the middle number, left and right again same. So what I can do is, if I just forget that I have a 3, I have these numbers, I just sorted them down to club all the numbers together. If I just sort them down, then all the 2's will come at one place, all the 4's will come at one place, and so on and so forth. Now if I just go on to, okay, let's say I equal to 1, 2, 3, 4, and like so on and so forth, like I equal to 1, then I equal to 4, which means just a plus 3 in I, and then every number, okay, if I just land at I equal to 1, then I equal to 1, what's the value it has, it should be same as the I equal to 0 and I equal to 2. That is, I'm gonna check to say, okay, all these are same. But as soon as a new element came in picture, now although you would be saying, okay, I equal to 1, then you would say, okay, it's same and same. Then I equal to, remember, it was I equal to 2, 3, 4, it was I equal to 4, you were checking next. If you would have checked I equal to 4, and as a element which was not in up order of 3, so it would land to some odd location, that okay, here, maybe here, or maybe here, but not in the middle. Now as it is not landing in the middle, I will just for sure know, okay, it is not equal to this, it is equal to this, which means if it is same and we know exactly once the number which is occurring, so for sure 4 and 4 are matching. It is not matching, which means something is wrong here, which means some extra element came in picture, and what is that extra element which is not matching for sure. So I can simply get it, okay, this is a 3 which is not matching for you. Thus by this I can simply go, because earlier I saw, okay, I have a pattern here. If it is not following a pattern, which means that element is the odd element which came in picture, so that is my answer, which is the number which I should not, like I should return. But in this you will see that, okay, you will start from here itself, then you will match here and here, which means you're starting from I equal to 1, right? I equal to 1. Although it is very simple, you can start from I equal to 1 itself. Still here it will go and again match. It's not matching, it will return. Ultimately, you will just land onto some number. It will just try to match here. It's not matching, it's going to return. So although you can also use this part in the code itself, and also what you can do is simply make it as an edge case or right here itself. Both is gonna work for you. But now you saw, okay, you found out a pattern in this, and then you just simply went on to say, okay, what element is not following this pattern is the element which is occurring only once. By this, because see, it was occurring thrice. Every element was occurring thrice. That is the pattern which we found out, and from that we found out, okay, one element which was not occurring, that's the answer. Same, we sorted all the elements to bring them, club them together, so O of n log n, but we have not used any space, so O of 1. It is one of the approaches. Now, sorting. Now, it is one thing which can come in picture for most of you. Now, you will say, Aryan, sorting, which means it's way much complicated than O of n, because earlier the time was O of n and space of O of n. You increase the space, see, you increase the time, so it's O of n log n. You will see that n, it will at max go to int max, which is a limit of 2 to the power 32. You will see that log n will always be less than or equal to 32. So time is ultimately a O of 32 into n, right? So that is kind of a roughly O of n itself, because it's a constant into n. But as we look at this constraint, okay, all the numbers are in the bit range of int max, which means I can represent every number as an integer, because see, it was one of the place where you can see the intuition, okay, maybe I can use some of the bit manipulations, because every number is in the integer bit range, which is the 32 bit range. And if I try to represent every number in the bit form, maybe I can figure out the pattern there itself, that I don't have to see. One way is to figure out the pattern in the numbers, and then other ways to figure out the pattern in their bits. I can see they have highlighted the point, okay, for sure we can think of in the bits form also. So I just thought, okay, every number is a 32-bit integer. Now let's see that if we represent every number in the bits, then what's going to happen. If I represent 2, so it will look like this. 3 look like this. Now 4 look like this. Now if I just see very carefully, ultimately what I want is, if I just go and see the sum of these bits, which means the sum of the bits at I equal to 0, which means the first place it will be 1. If I go look here, it will be 4. If I go look here, it will be 3. Now one thing for sure, you know, ultimately in your mind, that it is occurring thrice. It is occurring thrice. So every of those number which is repeating thrice, its bit will also repeat thrice. So for sure it will be some multiple of 3 plus something, which means, okay, here you saw this one, it came in because of this 3. So it is having 1 extra, multiple of 3 plus 1 extra. Here also you saw it was 1 extra, which means multiple of 3, which means multiple of 3, when I say it's 0, 3, 6. Now 0 was also right, because no one came here, but still 1 extra came in picture, simply 1 extra. So now you can just simply say, if I just simply go and add the bits, simply in this add the bits, and then if I just do a mod by 3, which means simply getting, okay, what's the remainder if I just remove the multiples of 3. Why I found the remainder? Because I know 3 will form the group. I don't want the group, I want the number which is remaining. if I just do a mod 3, it will land me a 1, which means, okay, one bit is at the I equal to 0. If I just do a mod 3 with this, it will again land me a 1, which will actually indicate, okay, it is the bit which is actually he is referring to, because it will form the group and it is just gone. It's not considered for me. So at I equal to 2, I just again found out a bit, and here at I equal to 1, I again found out a bit, and I equal to 2, I will just say, okay, it's a multiple of 3, then no extra bit for this element. For this element, the contribution is simply a 0. That's the reason I just simply get a 0. So ultimately, you saw, you can just do the addition of bits at every place, and then just do a simply mod 3, because we know, because 3 numbers will occur same. So it will for sure, every number which is same will occur thrice. So for sure its bit count will also occur thrice. So it's just simply do a mod 3. The number which is remaining will actually be representing the number which is occurring only once. That's how it is the next. And see, for me, it was more intuitive than the method 2, which we saw above, which means figuring out the pattern, because it's clearly visible that we have to think in the form of bits. As you start to think in the form of bits, you will simply see this pattern, and this pattern is the most intuitive pattern which you can find out. Now you know that this bit representation, every number, it can be represented as a 32-bit integer. So this, it can go at max a 32-bit spaces. So right now, you know, it's n numbers, and this, it can go to 32 bits, because every number can be represented in a 32-bit integer. So it will be n into 32 itself. Thus, I can simply go on all the elements, and simply for every element, I will represent that in a 32-bit integer form, and then simply add for every location, simply add what is the bit count, simply doing a sum, and doing a mod 3 to get, okay, what is the actual bit at that value. And then now I have the bit representation. Now I will convert this bit representation back to a number and will simply get my answer. Now let's quickly see the code. It's very simple. I just simply went on to all the bits, which means I equal to 0, I equal to 1, I equal to 2, to get this bit I equal to 0th bit for that number, right? As I go on, I know I have to find for every I know I have to find the sum of that bits. So I initialize a variable called as sum. Then I went on to every number, every of the n numbers, because I know for that ith bit I had to go at to every number. Then I went on to every number of my array nums. Then for that number, I just said, okay, hey bro, just get me this bit. Now when I say, let's say if I want to get the ith bit, so I can simply do one thing. I can simply make a mask and do a left shift of that mask and bring it here, which means if I just want to know, okay, what is this bit, right? What is this bit? Is this bit a 1 or a 0? So I can either do one thing. If it is the number, I can just simply do a right shift of this number and will make it as a 0 1, so that this number got right shifted I times, which means it was I equal to 1, right? So it got right shifted I times, and I will simply get at the last location that ith bit. Now I can simply do a and of I and with 1 with that right shifted number to get, okay, what is that ith bit. Or other way is to simply know, okay, it is 1. I will make a mask something like this to know if this ith bit was a set or not. Now if I had a 1, I will do a simply left shift I times to make a mask out of that and simply do an operation now. So anyways, either you can shift the number and do a and with your 1, or your 1 you can bring it left shift that 1 by I times and then make a number and then do an AND operation with your nums. Either way you can do it. Here in this example I did, see, it's very important to actually know this left shift right shift operation, making a mask and then simply doing an AND operation. It's very easy to simply know if this bit is set or not. Now here in this example I just simply did one thing. I just simply did a right shift I times, simply making it as a 0 1, which means this 0 is actually gone because right shifted it, which means the right bits are truncated. Now if it is remaining, I will just simply to know if this bit was set or not, simply doing an AND operation with 1. If we get a 1 here, for sure that bit was set. If we get a 0 here, that bit was unset. So I simply right shifted that I times did a AND operation with 1. If it is a 1, which means that bit was a set bit. If it is a 0, that bit was an unset bit. And simply if it is 0 or a 1, if it's a 1, I will simply add it in my sums. So my sum will actually increase, and ultimately I will do a sum whatsoever I have. Either I can do it here also, or as soon as the loop finishes, I can do a mod 3 at that point also. But see, I simply find the sum. Here, let's say for this number I equal to 1, I simply found the sum, which was 4. I did a mod 3, which is simply getting a 1. So I will just know, okay, the contribution of that particular sum for this particular location I equal to 1 is actually a 1. If it is not a 0, which means I have, okay, this one will have a contribution in my actual answer, because my answer was initially a 0, which means I initially my answer with 0. Now I have to make my answer back with this numbers, and for my answer I know it's a first bit, which means it's a 0th, it's a first, it's a second, its first bit is a set. So what I can simply do is, I know its first bit, which means its ith bit, is set. So I'll simply left shift my sum, because my sum, let's say my sum was actually a 0 1 0, right? My sum was saying, okay, hey bro, I am actually a 1. It's saying, hey bro, I'm actually a 1. So I'll just simply do a simple thing, left shift my sum I times, because my sum was 1, it will just saying, hey bro, I am 1, left shift me. So I will just become a I times. If I just left shifted you by I times, I will simply become a 0 1 0. Earlier, if I had just simply gone here, my answer would have been a 0 0 1, because I have simply used my I equal to 0. So I have at I equal to 1, when I landed on, I will get my sum as a 1, because for sure my sum was 4, mod 3 I got a 1, which is okay. I can add a contribution of one element as soon as I know, but that contribution of that one element will be at I equal to 1. So I will left shift my sum I times to get something like this. My 1 left shifted by I times to get this. I will simply do an OR operation with my answer to get a 0 1 1. So that my answer will keep on building with the actual number which I wanted by simply doing an OR operation. See, this can also be modified by simply doing by simply getting my 1, or simply doing its left operation I times. Anyways, it's just a left and right operation which you can do, and simply doing an AND and OR operation to actually bring out that number and actually add that number in your answer. Cool. Now by this, for every ith bit, you will just keep on going for this entire stuff. By this also, your time will be O of 32 into n and space O of fun. But still we can optimize this, and that is the most interesting part, to actually know that how the, because no one has told the intuition for that. I don't know why. It actually is the most important concept. How we know that, okay, we have 32 bits, and that's the reason our number was coming as 32 into n. But we need to optimize this, which means, okay, we have to remove this 32, because for sure I need to come to something like O of n as time and O of 1 as space. I have got O of n into 32, so for sure I need to remove the 32 factor in that, which means I have to not go at all the bits of that number, which means I will try to go on at every number, right? Now earlier I saw, okay, I was going on every number, I sorted those numbers down. Now sorted those numbers down to find a pattern in that, right? Let's say if the numbers are not sorted, or even if they are sorted, what if I can only get the, okay, if the number is coming as 1 time, if the number is coming as 2 times, if the number is coming as 3 times, why not? If I know, okay, if the number is coming as only 1 time, then that's my answer. If the number is coming as 3 times, okay, that's actually a good case, because for sure ultimately what will happen is, if I go and see, okay, 2, it came in, okay, it came in 1 time, other 2 came in, okay, now the 2 came in, okay, initially the 2 came in, it came in 1 time, so I'll put that in my 2, in my ones. Next time that a 2 came in, so it count has become a 2. So one thing is for sure, in this pattern, one thing is for sure, the count of every number, it can be either a 0 or a 1 or a 2, which means the count is restricted. It can be a 0 1 or 2. So I changed my variable And rather than going on to, okay, every number, every bits, I just took, okay, let's have three variables, ones, twos, and threes, which is the same, okay. This number has come in one time, it has come in two times, it has come in three times. Ultimately, in the end, it will help me if I just have ultimately, as I was saying, okay, a 2 came in, it is in ones. A 2 came in again, now it will come in twos. A 2 came in again, it will come in threes. Now, a 3 came in, it will come in ones. A 3 again, like might have come in, so it would have come in twos, right? But now let's say a 4 came in, so it will come in ones. A 4 came in, it will come in twos. A 4 came in, it will come in threes. Now you saw ultimately what was happening was, okay, Aryan, but in this you are bringing in every number again and again in this. Let's hold your horses. We'll go on to that. But one thing you for sure know, okay, ultimately in the end your ones will have just the one number which will have, and threes will have all the numbers, which we don't want for sure. We only want ones. But it is one thing which we can think of, okay, maybe I can do something like this, because I just want any number which is occurring once, twice, or thrice. Now comes the actual part. If I have got this 2, okay, it has came in just one time, so I'll just put that in my ones. Okay, 2 has come just once. As soon as another 2 came in picture, for sure it will never remain in ones, it will come in twos. Another 2 came in picture. Now, do I need to make a 3 variable count? No, right? Because ultimately I'm not concerned about 3. I need ones, because for sure I need to know, okay, what is the element which is occurring only once. I need twos, because for sure as soon as the element came in once, and again it's coming in, I need to put that in twos. But I didn't, why to put that in twos? Because ultimately the 2 is not required for you. But let's say the element again came in, how would you know that if it had come only once or only twice? If the element is again coming in, for example here in this case, you should be knowing, okay, if it had occurred twice, so you will just go and ask, hey bro, do you have that 2 with you? He said that, yeah, bro, I have 2 with me, which means that number 2 has occurred twice. So I'll simply go and say, okay, that number should have gone to threes, but 3 is ultimately entirely done. I don't want to go on 4. So I'll just simply say, okay, 3 is something I don't have to output in my answer. So please not take the variable as 3. That's the reason I just skipped 3 as putting in. But it is actually removing from ones and twos itself. Now you saw as again a 2 came in picture, it just removed. Earlier the 2 had a 2, the 2's had a 2, but now it is gone. No ones, no twos. Again a 3 came in picture, now my ones will have a 3. Now it is something which we saw at a high level. Now let's see how we're going to actually solve it in a problem. As soon as the 2 came in picture, I have to put in my 2 in my actual ones. But I can't go and putting in all the variables here, right? I can't go and do a search on all the variables, because for that it won't have a complexity of O of n. I need to modify this. As soon as initially my ones was a 0, initially my twos was a 0, representing, okay, I have not got any number so far. As soon as I got it, initially my ones was a 0 0. Mark my words, I'm representing this number in the bit form, because for sure above we found out, okay, we can use bits somehow. Let's see how we're going to use it. We saw a pattern. We can use ones, twos, and threes. Threes we skipped because we know that it's not useful. We know, okay, we can use the ones and twos. Now, using ones, twos, using a bits, let's see that how we can build the solution. Okay, we know we had a ones, 0 0. Now, as soon as a number came in picture, which is actually a 2, representing as 1 0. Now, I need to put in, because my ones, it was actually saying, okay, bro, I am a 0, which means ones is saying, bro, I have not occurred. If I have not occurred, which means the 2 has not occurred, and ones is a 0, which means simply add this 2 in your ones, which means, okay, now ones, it should have 2 as a value. For that, you have ones as a 0 0. You have the nums as 1 0. For sure, if I need to make my ones as a 1 0, which means a 2 itself, so I have to do, okay, 0 0 1 0. So either by doing a simply OR operation, I can make ones or nums of I can make a ones as 2, or I can do a ones or nums of I can still make my ones as 2. So for sure, to make my ones as a 2 came in picture, to make my ones as a value 2, I can either do a OR operation or I can do a XOR operation. I can do a AND operation because after AND it will again become a 0 0. So for sure I can't do an AND operation, but yeah, I know I can either make my ones by doing a ones or nums of I, or I can do a ones XOR nums of I. So that my ones will become a 1 0, which is actually a 2. So one thing I got to know, okay, I can do something like this. Maybe let's go forward. As soon as a 2 came in picture, now what happened was earlier your ones was having a 2 and your twos was having a 0. As soon as a 2 came in picture, you know one thing. You have to modify this 2's, which was actually a 0, now to a 2. Same as we did before. We can now, because earlier you saw that your ones was a 0. Now you modified that ones to actually that number itself, which is 2. So you simply can do both the OR operation and the XOR operation. So for the 2's, I can do simply both OR operation also and a XOR operation also to make that 2's actually to a 1 0. By this, either by a or either by a XOR, I can simply make my 2 to my variable called as 2's from 0 to actually a 2. But if the 2 has came in picture, which means the 2 frequency you saw, okay, it has become a 2. So you place that 2 in the 2's count, but in ones it should also be removed because its frequency is no more 1. So from ones the 2 needs to be removed. Now you saw the from ones it needs to be removed, which means again if you do from ones again if you do again, once was actually itself a 1 0. Again if you do a 1 0, it should have become a 0. That's the reason I can't do a OR. If I had used a OR, it would have again remained a 1 0 itself. So I can't use a OR. One thing I got to know, okay, I had two options, either a OR or a XOR. Earlier I had a XOR and an OR. I realized that I can't use the AND. Okay, cool. Then I had option of OR and XOR. Here also I realized if again it came in picture, from once I had to remove it. So for sure I can't use an OR also, because if I used an OR, it will remain same. It will remain a 1 0 itself, but I don't want to use it, so I will use a XOR. So for sure I got to know, okay, once will be a once XOR nums of I, which means 1 0 1 0. It will do a XOR. It will again land to a 0 0. So now my ones, by doing a XOR operation back, it has become a 0 0. So I know one thing for sure, I will use a XOR operation. From this so far you have got to know one thing. Adding nums of I to this set. Let's imagine this as a bucket. As soon as you add that in your bucket, and if it's already not in the bucket, which means already not in the bucket, that number was not in the bucket, which means 0 was there, not in the bucket. You added that number, so the number will actually be added in that bucket. But if you are removing nums from the bucket, and if it's already not in the bucket, which means, okay, if it's already in the bucket, then you have to remove that from the bucket, right? So if it was already in the bucket, which means if it was already in the bucket, now you are going to add that number in the bucket. So for sure it needs to be removed in the bucket, because once it has 2. Again, if you are adding a 2, which means it should not remain in ones. It should have gone to 2. For sure, it will go to 2, but it should also not remain in ones itself, right? So if it was already there, again it's coming in, so please remove it. In ones, 2 was already there. Again it's coming in, so it will for sure go to 2. That's one thing, but it should not remain in ones. It's coming in again, please remove that. It's coming in again, please remove that. And please remember, it has nothing to do with the order of numbers. You realize, because everything is being applied on the bit level. So if that bit is having anything extra, then it will get removed. If that bit was coming in, okay, for the first time, which means it was not there, it's coming in, please, you can for sure very well come in. If it was already there, now it's again coming in, so please you go and remove that. So basically you saw everything is being operated internally at the bit level, thus the order is nothing which we matter about. Now cool, We know one thing, as soon as the new element comes in picture, we have to do something like this as a XOR operation. Now coming on to the next number, as soon as the next element comes in picture, we know that we had earlier a 0 and a 2, but as a new element, a 2 came in picture, you have a ones, which is a 0, saying I have no ones. A 2 came in, so because of this, he is saying, bro, I have no ones. A 2 came in picture. So shall I put this ones as a 2? No. Because this ones is also impacted by this 2's. Which means ones as a 0 is saying that, okay, I have no ones. But please also make sure that you have to see that if you have no 2's also. If you have no 2's, no ones, and only you can increment your 1. But if you had no 1, but you have a 2, which means as soon as a new element is coming in picture, it is coming as 3 and not a 1. So as soon as a new element came in picture, I'll go and ask, hey bro, 1, you have a 0. Shall I place a 2 for you? Because here also in the initially you saw, right? Here the ones was 0. Here the ones was 0. Now you replace that by 2, but you could only replace that because the 2's was a 0. Initially we did not know, okay, we have to also look at this 2's also before modifying ones, because we are going intuitively. But as we are placing a new element, again 2, we realized we can't modify ones. Instead, we have to modify 2's. So we got to know a bigger condition. We have to perform above operation on ones. We have to perform above operation on ones only if not present in 2's. If that is not present in 2's, here 2's, here 2, number 2 was present in 2's. So I cannot perform this operation on ones. So ones will remain a 0 and 2's again will become a 0. We will see how that will happen, but it is a condition you saw. We can apply above operation, which you saw, applying operation of replacing that number, adding that number, okay, from this from this is 0, it formed to 2. From here you saw, okay, the number 2 is 0, it formed to 2. Here you saw the 2 formed to 0. Now again it is a 0. Shall you place it a 2 here? No. You can only apply the above operation only if it is not present in the other thing, which is 2. Now writing the same English statement in actually the bit form, not present in 2's. 2's I will write, not present in, I will write a not operation. Only if, which means for sure it is condition combined condition, which is an AND operation. Above a thing which we saw, above thing, simply doing it is simply a value which was saying, okay, existing value, right? Existing value was of ones. So it was nothing but ones. Nums of I XOR ones. Nums of I XOR ones was the existing value. Existing value, perform operation on the existing value. On the ones, it was nothing but ones into ones XOR nums of I. So once it can only become that number if that is once XOR nums of I, once XOR nums of I and not 2's, which means apply above operation only if it is not present in 2's. Add a 2 in ones, adding a 2 in ones by this simple operation which we saw, adding a 2 in ones. Simply, if it's a 0, it will add a 2. If it's already a 2, it will add a 0. But we can apply this operation only and only when it is not present in 2's. That's the same thing which we want to do. As we saw, the same thing which we did for ones, we did the same thing for 2's also. Same thing which we did for two. Same thing which we did for 2's also, right? That's the reason what we will do is same thing which we'll do for 2's. 2's is equals to 2's XOR nums of I, which means if the 2's has that value, bring it as 0. If 2's does not have that value, then make that value up. If it is a 0, if it comes in as a 4, then make it as a 4. If it is already a 4, then please make it as a 0. But this operation will only, which means if it has been a 0 and a 4 came in picture, then it can only be applied if in ones that is not present at all. Which means if in ones it is not present, it is saying, okay, bro, I am a 0. That means, hey, bro, that not operation, which means I am not present, okay, it will just give me 1. That will make sure, okay, I can simply add the 4 in my 2's. And that's how you know that your condition initially it was 2's is equals to 2's XOR nums of I. Then as you go on moving forward, you realize that you also have to add an AND condition with not of ones. And similarly, same thing goes for ones also. And that's how you can simply get to your actual condition. That okay, I have ones, and that's how, and that I simply use the example itself. Going on, okay, if I just add the one element, then I add the next element, then I add the next element, and just adding these next element, and see, it's very simple. Now again, your ones and twos have become both zeros. As the 3 will come in picture, he will ask, bro, you are a 0. I can add my 3 come in you, right? I can add my 3 in you. I can add my 3 in you. Yeah, you can add. Provided the 2's is actually a 0. Yeah, it is actually a 0. So I'll ask him, beta, mine is 3. I'll do an operation with, okay, whatsoever you have. Okay, it's a 0, which means good for me. Good for me, okay. If it is a negative, which is good for me. So I'll do a negation of 0. It will give me a 1. So for sure, I can now add a 3 in me. I'll simply go and add a 3 in me. Now, when I say negation of a 0, it's actually a 1, 1, 1, 1, if you know. So, right, that's the reason it will just give me a 3. That's how you can simply go and add in your ones and twos, ones and twos, ones and twos. And when I say it's a contribution of that bit, that's the reason the order won't matter for you. Now, simply writing the same condition, simply doing a ones, it is nothing but ones XOR nums of I and not of twos. Simply for twos, a 2 XOR nums of I and not of ones, going on to every element and simply going and doing that operation. And simply ultimately, if one element is remaining, for sure that will remain in the ones itself. So I simply go and return the ones, and that's how your time will be overfin, specifically overfin. I hope that you guys got it. I got into a complete intuition of this fourth because for sure in interview you have to speak the intuition, not the logic. I have seen many people saying that okay, it's not intuitive, you can't think of intuition, you can't go on it. But if you just go and directly say, although initially it's hard, but if you just go in the intuitive way, and please remember the links and not the actual logic entirely. Remember links, okay. Aryan told that we can maybe think of okay ones twos, but to convert in that ones twos, what I have to convert is just to see okay what is the contribution if I have one element coming in, next element coming in, next element coming in. Now think in that way. When you revise, when you think in that way, then only you can remember the entire intuition. If you just go and do a rectification of the intuition also, then intuition is not having that meaning. It should remain in your mind as links and not the entire logic. Don't remember the logic, just remember okay links using ones twos as the variable, as the count. That's the one thing, that's a link. With that link, it comes in the bigger picture. Cool. I know the video has gone long, but yeah, that was actually a very important, very kind of me for me. I have seen that okay, it's actually a hard question and not a medium one. So yeah, that's all. Bye bye.